So the first thing we need to understand is, where does the force act? Because we know that any motion, the root cause of any motion is force. Okay, so if you have an object going in a circle, let's say a car or whatever, right? It starts over here and it wants to go in a circle. Which way must the force act? So a couple of options is the force going this way, the main force that causes it to go in a circle. Is it going this way, pointing towards the center of the circle? Is it going outwards, backwards, or at an angle, or zero? Okay, so these are the options. Take a quick think about it. Now, let's do by process of elimination. First of all, can it be zero? I think no, right? Why no? Because of Newton's first law. We learned that, again, why Newton's first law is correct. Well, we've talked about it in the video about fundamental laws. If there is a reason in modern day that we now know, but in the time of constructing all these theories, it is really just an observation, okay? And it's an observation that seems that almost everything, and as far as we know, nothing really violates Newton's first law up to this day. So it's an observational fact that is pretty reliable. But asking why is a really, really deep question, right? So we won't go there. But what does Newton's first law says? It says if there is no net force on an object, sorry, I should have clarified, I'm asking net force. If there's no net force on an object, then it will either stay at rest if it was at rest, or it will stay in continuous motion in a constant velocity. That means it's same speed and same direction. Now, this object is clearly not going in the same direction. It's changing direction all the time. Right over here, it's going forward. Right over here, it's going leftward. Over here, it's going downwards. Over here, like this. Right. So it's changing direction all the time. So it cannot be zero. Okay. Now, the next thing you might think is there a force pushing it forward? Now let's think about it. This depends on what is your speed really changing, right? And what we are going to study is a very special type of circular motion as well, called uniform circular motion, which means with constant speed. Not constant velocity, that's impossible, that's a contradiction, right? Constant velocity means the same direction as well, which is just a contradiction. But we can move with the same speed, okay? So we're not speeding up. So I don't really need a force to push it forward. That is not really the point. It doesn't have to be pushed forward in order to move with the same speed. So that is not actually the force that there is. Same idea of this of pointing backwards. That's not really the force there is. Okay, so now the biggest the probably most student would think is even for myself, the first time I looked at this, I thought this is going to be force because it is trying to make it go in this way, right? So it has to accelerate this way. Now I would be in the right logic, but let's think about it now that we know how vectors work. Is you can break this into components. You can break it into this x component and a y component. So basically, you're saying that there's part of it that's pushing it forward and part of it that's pushing it inwards. Now, we have just eliminated the forward one. If there is a part that is pushing it forward, it will probably increase the speed as it goes along, right? Because I'm just drawing one instant of the car, because if it moved over here, and if you use the same idea that the force should be some diagonal direction, then there will always be a component that is pushing it that is forward in terms of the car. Does that make sense? Right? So that component will just keep speeding it up in that case, right? So now let's give it some names. So let's learn some terminology. This is called, so instead of me just keep saying forward or left and right, because left and right really is not a good idea, because the moment the car is on top, this direction towards the center of the circle now becomes downwards, right? And I don't really want gravity at the moment, you know. So let's use a better terminology, and the two terminologies called tangential and radial. Okay, so this is the radial direction, and this is the tangential direction. So these are very useful words when talking about circular motion. So tangential means it's tangent to the circle, okay? So if the car is over here, this is the tangential direction, okay? I can still have forwards and backwards. Let's say the car is going this way, but that's the tangential direction. And this is the radial direction, and that rhymes with, or comes from the word radius, right? So it's along the radius. So in this case, this is the radial direction. So we call this, if we want to describe these in words, these are very useful words. We call it radially outwards. Radially outwards, or radially outwards, and radially inwards. Tangentially forward and tangentially backwards. Okay, so these are useful terminologies to speak of. Okay, so what I am saying is, if there is a force like this that is diagonal, you can break it into a tangential component and a radial component like this. Okay, so you have and now you realize that because every force basically what does force do in Newton's second law? Force provides an acceleration, right? Force is the root cause of acceleration. So if there's a tangential component to the net force, then you will accelerate in the tangent direction, right? That means you will go faster and faster, and that's no longer uniform circular motion. Okay, so now it already goes to the hint that there must not be any tangential component, and purely in the radial direction, right? So purely along the radius, and now it's hinting to the correct answer, and the correct answer is this. This is the force that is responsible. That should be the only net force that exists. You should not have any other forces if you want something to go in a circle. Not even slightly, it's very counterintuitive if this is the first time you heard about this. So let's write that down, right? So for things to go in a circular motion, to go in a uniform circular motion, there must only be a radial force towards the center. Okay, so the direction, this is the key point, towards the center, and we give that a name. Forces that all constantly points towards the center is called a centripetal force. So you can write that down, right? A centripetal force is a radial force that always points towards the center. So what that means is when the car is over here, all forces should cancel out except for the ones pointing towards the center. Okay, then that is, you must have a net force pointing towards the center for it to go in a circle. So when it is here, that is the net force. When it is here, that is the net force. When it is here, that is the net force. When it is here, that is the net force. Okay, so that's one way to think about it. I'll give you another way to think about it as well. So this is really the key concept of centripetal force. So centripetal force is the one that's responsible for, you can see the word comes from center, right? It's a central, so it's pointing towards the center.